now we're going to use one case study. Actually, the data is public, so you can see at the bottom, this is public data. You can go and download and play with the data set. So the case is very simple. We want to maximize the concrete strength, right? We produce concrete. So we have all different mixtures, water, cement, super plasticizer, some ash, whatever mixture. But I want to see the maximum or concrete strength, right? So how to mix. And also I have some requirement from our customer. They say your concrete strength must be at least 20 megapar. So this is the strength rating.
예, 지금 사례는 이제 콘크리트 강도에 대한 사례입니다. 그래서 콘크리트를 구성하는 여러 뭐 인그리디언트들이 있을 거예요. 뭐 시멘트부터 물, 기타 등등. 그래서 강도를 높게 하는 게 목적이겠죠. 근데 최소한의 강도 이상은 돼야 될 것 같고요. 예, 그 사례를 소개해드리겠습니다.
Now we have some available data. So based on our history, whatever we have produced. So we have about 1,030 observations, which is 1,030 batches of concrete. And we record their mixture, which is like we have variable how much cement we put in, how much furnace we put in, how much ash we put in, and water, super plasticizer, aggregate, whatever. And the age means I leave this concrete for how long, right? And also I measure the end, which is concrete strength. So that's gonna, in the last variable, gonna be the strength. I plot the data, about 1,000 whatever variables. About 19%, you can see using Minitab, very easily to work out. This part was less than 20 megapar, not qualified. Your customer won't be happy. And the minimum requirements is 20 megapar. So you have available data in front of you, which is 1,030 batches.
예, 지금 이 회사 사례는 지금 품질 수준이 굉장히 안 좋습니다. 거의 한 20% 가까이가 지금 디펙트 수준인데요. 그래서 콘크리트를 구성하는 여러 인자 수준이 있고 데이터는 한 1,030건 정도 예, 측정을 했고 이제 공정력 분석까지를 일단 해보았습니다.
Okay, so I'm gonna start with something like scatter plot, right? People always think of look at the numeric variable. I look at relationship between like a strength and all other variables, like a cement strength. Yeah, sort of relationship, and sort of, but very hard to sort of give you a very concrete conclusion, which means I can't. Based on the scatter plot, I have some idea, but there's no concrete plan what to do next, right? Which variable going to be in the model, not in the model? I can only give some general impression.
예, 먼저 이제 산점도 보통 그려보잖아요. 그래서 지금 보시는 것처럼 그 비선형성이 존재해 보이고 그리고 어떤 딱히 어떤 관계를 좀 찾기가 어떤 특정 변수의 중요성을 찾기가 지금 현재 어려운 상황에 있습니다.
Yeah. We can also look at the correlation between X and Y variable. Look at the numbers, right? We see cement and the strength, the correlation 0.49, bit strong. And also there's some correlation between X variable and X variable, which means looks like a water and fine aggregate and super plasticizer and the water. So they have some X and X correlations as well. But again, based on this, I still don't know what's kind of related, what should I do next?
예, 여기서 이제 이 correlation 매트릭스로 대략은 그 계수값으로 관계를 좀 알 수 있겠죠. 예를 들면 X와 Y의 관계 혹은 X와 X의 관계. 근데 아직도 여전히 좀 만족스러운 그런 인사이트를 좀 얻기가 어려운 상황이 있습니다.
So these tools are in Minitab and SPN, right? It's very easy to find out. Okay, now we try modeling using traditional statistical tools. For example, regression. You know, Minitab, they have the tool called stepwise, which means it's going to build a model automatically for you. With 1,000 observations and about 10 variables, you dump into the software, it generates a model like this. Looks like lots of p-value is going to be low, which means many interactions, many variables are significant. And with R-square only 71%. So it's not too bad, but sort of not the ideal, right? We're looking for higher. So why? Because observations. So if you look at 1,000, normally when you build a model, you're not looking for 1,000 observations. So because a huge amount of data, so the test is very sensitive. It detects a very small shift, either from age or from interaction. That's why you always end up with this, with a huge amount of data. So this is called a regression wall. We come to a regression, we hit a wall, we don't know what to do. Even with so many significant variables, but we don't know what to do.
예, 지금 이 상황에서는 이제 한 1,000개 관측지의 데이터를 가지고 회귀 분석을 돌렸습니다. 그래서 이제 모형을 여러 차수까지를 다 넣어서 돌려보니까 이제 대부분 p-value가 다 유의하게 나왔어요. 이제 모형이 사실 굉장히 복잡할 겁니다. 저게 다 유의하게 나왔기 때문에. 그럼에도 불구하고 이제 예를 들면 또 아이스케어는 조금 만족스럽지 않은 수준이고, 그래서 지금 이 상황에서는 회귀 분석으로 뭔가 결정하기가 좀 담당자 입장에서는 좀 만족스럽지 않은 상황에 지금 놓여 있습니다.
So after trying traditional tools like Minitab, statistical, we probably try something different, right? We try SPM. Let's see what can we do with this software SPM. So I switch to the software. So I'm gonna run this. I open the data file. So here is the concrete data. So we have 1,030 observations. We record how much cement we put it in this mixture, how much fly ash, water, and super plasticizer, and some other aggregate, right? All the mixture. And we leave it for how long is the age? We leave the concrete for 28 days, and we measure the strength, 79 megapower. All right, so this is the data we have. So we want to find out what are the key variables, right? I want to maximize concrete strength. So we're going to do modeling.
예, 지금 데이터셋을 보시고 있고요. 이미 설명드린 대로 이 스트렝스 Y 데이터가 있고, 그다음에 X의 여러 가지 데이터류가 있고, 이제 시멘트 양부터 해서 에이지는 얼마만큼 이제 그 지속시켰는지 데이일 수도 있고요. 예.
Alright, so this time we're going to use the strength as my target variable because I want to maximize strength. And the rest we use as predictors. Since we have the numeric, we go for regression, right? We're going to regression techniques. And we're going to use a techniques called TreeNet. You see in SPN, there are several algorithms. They are slightly different, but I can explain this later. We go to TreeNet. Yep. We just change a little bit of this settings to 0.1, and under testing, we use validation. So what does it mean, validation? When you do machine learning tool, you have huge amount of data, right? But when you build a model, you don't use all the data to build a model. We call this overfitting. So, for example, everyone gonna have had experience in high school, right? When you go to high school, they're gonna give you exam. For example, we talk about the subject is history of Korea. We have 300 questions. That's a question pool. And I want you to study. So teacher gonna give you questions you wanna study, and we're gonna examine you later. The teacher only gave you 200 questions from those 100, from 300. So 200 out of 300, study. So you have the answer, you have the question, you study. But when we test it, whether you study well or not, we don't use those 200 questions. We use those 100 questions left to test whether you study well or not, right? Because they are in the same kind of topic. So same thing here. When we build a model, we're going to use part of the data, run the model, and the part of the data to test the model. If it's a good model, it's based on the test result. So always like this kind of algorithm called validation.
예, 조금 세부적인 얘기를 했는데요. 일단은 변수 선택을 했고요. 그리고 머신러닝의 여러 알고리즘 중에서는 트리넷이라고 하는 알고리즘을 선택했고, 그다음에 저기 보이는 여러 탭들이 있습니다. 사실은 저 탭들이 클릭으로 할 수 있는데 기존에 아시는 뭐 R이나 기타 등등은 저걸 다 코딩을 해야 되는 거예요. 이제 그런 것들이 강점이라는 걸 제가 조금 설명을 드리고, 그리고 머신러닝의 가장 중요한 거는 학습과 밸리데이션의 비율을 얼만큼 해야 될지가 굉장히 중요합니다. 안 그러면은 그 잘못하게 되면은 그 학습은 잘했지만 실제 예측을 못하는 문제가 나오게 되거든요. 그래서 그런 부분들을 여기서 옵션을 잘 선택을 하면 되지만 여기 안에서는 일단 최적의 조건이 설정이 돼 있는 상태에 있습니다.
Now we choose one of the algorithm called TreeNet. Whatever name, you don't need to worry. But actually, this algorithm won many titles. So in terms of accuracy, in terms of predictivity, very good. So what's the algorithm?